In this video, we are going to look at the remainder theorem. So here I have my first question, which I'm going to use to demonstrate the remainder theorem. So I have this function f of x here, which is 4x cubed take away 5x squared plus 2x take away 3. And we're going to divide it by x take away 2 for part A and 2x take away 3 for part B. Now for this question, we want to find the remainder when we divide this polynomial by these two linear expressions. Now first, I'm going to use the division of polynomials to see what the remainder will be for the first one. Then we'll look at what the remainder theorem is, and we'll apply it for the second one. So for part A, this would be our dividend, and this would be our divisor. So I'll have x take away 2 into my polynomial, which is the 4x cubed take away 5x squared plus 2x take away 3. Now for a more detailed explanation of the division of polynomials, you can see my video for division of polynomials. I'll put the link in the description, and also you can click this card at the top. So I'll say x into 4x cubed, which will give 4x squared. Then I'll take this 4x squared and multiply by these two terms in my divisor. So 4x squared by x would give 4x cubed. And then I'll take the 4x squared and multiply it by this negative 2. And that will give negative 8x squared. And then I'll subtract the 4x cubed with the 4x cubed and the negative 5x squared with the negative 8x squared. So subtraction signs here. So of course, these two things are the same thing. So when you subtract, you'll get 0. So I don't need to write 0. And now I'll have negative 5x squared take away negative 8x squared. So now these two negative signs will give you a positive sign. So what we have is negative 5x squared plus 8x squared. And if you want, you can write that out as negative 5 take away negative 8. So you see the two negative signs will give you a plus sign. So negative 5 plus 8. So the two signs here are different. So we're going to subtract and take 5 from 8 and get 3. And since 8 is a bigger magnitude and the sign in front is positive, it's going to be positive 3. So therefore, this negative 5x squared take away this negative 8x squared will give you positive 3x squared. So we get positive 3x squared. And now we bring down this positive 2x. So we're going to write positive 2x here. And now we're going to say this x into this positive 3x squared, which will give us positive 3x. So we get positive 3x. So now we're going to multiply the positive 3x by the x and also the negative 2. So positive 3x by x would give you positive 3x squared. And the positive 3x by negative 2 would give negative 6x. And again, we're going to subtract. Of course, 3x squared take away 3x squared will give you 0, so we don't have to write anything. And now we have positive 2x take away negative 6x. So if we look at that, positive 2 take away negative 6. These two negative signs will get a positive sign, so 2 plus 6. So 2 plus 6 is 8. So what we're going to get here is positive 8x. So I can just write 8x. The sign in front is understood to be positive. And now we bring down the negative 3. So I'm going to write negative 3 here. Now I'm going to say this x into this positive 8x, which will give positive 8. So I'm going to write positive 8 here. And now I'm going to multiply this positive 8 by these two terms in my divisor. So positive 8 by positive x will give you a positive 8x. And the positive 8 by negative 2 will give you negative 16. And of course, we're going to subtract again. So obviously, 8x take away 8x will give 0, so we don't write anything here. And now what we have here, we have negative 3 take away negative 16. So if we write that out, we have negative 3 take away negative 16. The two negative signs in the middle here, and you multiply them, you're going to get a positive sign. So we have positive 3 plus 16. Again, the two signs are different, so you're going to take away 3 from 16 and get 13. And of course, 16 is a bigger magnitude. The sign in front is positive, so you get positive 13. So what we're going to write for the answer for this will be positive 13. And since it's the only thing, we just write 13. I thought to put a positive sign in front of it. So this 13 will be our remainder when we divide our polynomial by this linear expression. Now this question didn't ask for the quotient. They just wanted the remainder. So yes, you can use the division of polynomials to get the remainder, but there's a shorter way, which is the remainder theorem. So now let's look at the remainder theorem. So what you do for the remainder theorem is that you take your divisor, this x take away 2, and put it equal to 0. So you're taking a divisor, putting it equal to 0, and solving for your variable. So I have x take away 2, my divisor, put it equal to 0. My variable is x, so I'm going to solve for x. So I carry negative 2 across the equal sign, I will turn to positive 2. So I'm going to get x is equal to positive 2. So I'm going to take this x equal to positive 2 and substitute it for the x in the dividend, and that will give the remainder. So I'm going to write out the dividend, which is f of x is equal to 4x cubed, take away 5x squared, plus 2x, take away 3. So now to substitute the 2 into this polynomial, we'll have f of 2 is equal to, see I replace the x with 2. So everywhere you see an x, you replace it with the 2. So x cubed, we're going to have 2 to the power 3. Take away 5x squared, so we're going to have this 2 to the power 2 here, plus 2x, so that's plus 2 times x, so 2 times 2, take away 3. So now that will give 4 times 2 to the power 3, so that's 2 by 2 is 4, by 2 is 8. So we're going to get 8 here. Then we're going to have 5 times 2 squared, so 2 squared is 2 by 2, which is 4. The 2 by 2 here will give you 4. And then you have to take away 3. Now just a reminder of BODMAS. You work brackets first. And the O in BODMAS, which comes right after the B, is power of, which means you have to work out powers before any of the 4 operations. So I couldn't just say, hey, I'm going to multiply the 4 by 2 and ignore the cube here. Yeah, I deal with the power first before I can multiply by the 4. So now I can do the multiplication. So 4 times 8, 4 8s are 32. 5 times 4, so we're going to have negative, 5 4s are 20. Then we have the plus 4, take away 3. Now if you want, you can put all this into the calculator and work it out. So I can put in 32, take away 20, plus 4, take away 3, and as you can see, we get 13. So my answer is 13, and of course this 13 is the same as this 13 here. And of course, this 13 is our remainder. So as you can see, this is a lot shorter than using the division of polynomials to just get the remainder. Now, if the question asks for the quotient and also the remainder, then you have no choice but to do the division of polynomials. But if the question just wants the remainder, then use the remainder theorem. Now, I'll do a next video on the factor theorem, but the factor theorem is similar to this. The only difference, instead of getting a number for the remainder will be 0. Because remember, whenever we have a remainder of 0, both our divisor and our quotient will be factors of our dividend. So for the factor theorem, you'll still put your divisor equal to 0 and solve for your variable. Substitute that number into your dividend, and you're supposed to get the answer 0, which will be your remainder, and that will be the factor theorem. So now let's look at part B, when we divide this polynomial by this linear expression and see what we get as the remainder using the remainder theorem. So for part B, my linear expression is 2x take away 3, and of course that will be my divisor, so I'll put it equal to 0 and solve for my variable, which will be this x here. So I carry across the negative 3, it turns positive 3, so 2x is equal to positive 3. Then this 2 is being multiplied by the x, so when I carry it across, the operation changes to division. So we get x is equal to 3 divided by 2. And now I'm going to substitute this x equal to 3 over 2 into my dividend. So recall your dividend is f of x is equal to 4x cubed take away 5x squared plus 2x take away 3. So now to substitute this x value into this polynomial, everywhere you see the x, replace it with 3 over 2. So we're going to have f of 3 over 2 is equal to 4x cubed, so we have 3 over 2 cubed. Take away 5x squared, so we're going to have 3 over 2 to the power of 2, plus 2x, so that's 2 times 3 over 2. Take away 3. Now, a calculator can work all this out for you. Just use the brackets and the yx button to raise to the power, and you're good to go. So let's do it on the calculator first. We have 4, open brackets, use the fraction button, 3 over 2, close the brackets, and then we want to raise it to the power 3, so you can use the yx button and then press 3. take away 5, open brackets, 3, use the fraction button, over 2, close the brackets. Okay, let's press the x squared button to square it. Plus 2, open brackets, 3 over 2, so 3, fraction button 2, close brackets. Take away 3, equal. So we get 2 1/4. So you see how simple this can be done on the calculator? Now let's work it out manually. So as we know, laws are indices. If you have 3 over 2 to the power 3, of course, BODMAS, you must work the powers first before we do any of the 4 operations. So I'm going to have this is equal to 4 times, and I'm going to have the 3 to the power 3 and also a 2 to the power 3. So that's 3 to the power 3 over 2 to the power 3. Close brackets. Take away 5, open brackets. Again, the power has to go both on the numerator and denominator. So we're going to have 3 squared over 2 squared. Close brackets. I mean, if you want to multiply this one time, you could go ahead. This will be 2 over 1 multiplied by 3 over 2. So this 2 will cancel this 2. And what we remain with is just the 3. So you have 3 take away 3. And of course, this positive 3 take away 3 will just give you 0. So you can see this cancel out. This is nothing. So let's cancel it out like that because you're going to get 0 there. So now our focus is just on these two. So I'm going to put this is equal to 4 times, open brackets, 3 to the power 3. That's 3 by 3 is 9, by 3 is 27. So that's 27 over 2 to the power 3. That's 2 by 2 is 4, by 2 is 8. Take away 5 times 3 squared is 9, and 2 squared is 4. And of course, we have 0 here. So now, of course, this is 4 over 1 multiplied by 27 over 8. So the 4 and the 8 will cancel. 4 into 4, 1. 4 into 8, 2. So I can do that. 4 into 4, 1. 4 into 8, 2. So we end up with 27 over 2. Nothing will cancel here because this is 5 over 1 multiplied by 9 over 4. So I multiply the 5 by 9 and get 45. So we have 45 over 4. So I'm going to have 27 over 2 take away 45 over 4. So this will be equal to, put this line here, our LCM between 2 and 4 just before. So we have 4. 2 into 4 is 2, and 2 by 27 would give 54. Take away 4 into 4 is 1. 1 times 45 is 45. And this would be equal to 54 take away 45 is 9. So we're going to have 9 over 4, which is equal to 4 into 9 is 2. And remainder 1 over 4. So 2 1/4. So this 2 1/4 would be the remainder when this polynomial is divided by this linear expression. Now notice, in order for the remainder theorem to work, it must always be divided by a linear expression, not a quadratic, not a cubic, not a polynomial, a linear expression. So in my second question here, I have this polynomial that is divided by this linear expression, 2x take away 1, and we're saying that the remainder is equal to 3. Now we want to find the value of the constant k. So this k is a constant, which is here, and we have our variable, which is x. So this 2x take away 1 will be our divisor, and this polynomial here would be our dividend. So we know if we put our divisor equal to 0 and solve for our variable, and then substitute the answer we get for that variable into the dividend, we would get the remainder of 3. That's the remainder theorem. Let's apply it. So I'm going to take my divisor, which is the 2x take away 1, put it equal to 0. I'm going to solve for the x, carry across the negative 1, turns positive. So we have 2x is equal to 1, carry across the 2, the operation will change from multiplication to division, so I have x is equal to 1/2, 1 divided by 2. Then I'm going to write out my dividend, which is f of x is equal to 6x cubed take away 11x squared plus kx plus 7. Then I'm going to substitute my answer I got for my variable, x is equal to 1/2, into the dividend. So I'm going to have f of 1/2 is equal to 6 times 1/2 cubed. Take away 11x squared, so that's 11 times 1/2 squared. Plus kx, so that's k times x, so that's k times 1/2. Plus 7. Now again, BODMAS, we're going to work the powers first before any of the 4 operations. So we're going to put this equal to 6 times. Of course, we know we're going to have to cube the 1 and also a 2. You can do that one time and say 1 cube is just 1 and 2 to the power 3 is 8. So you're going to have 1 over 8. Take away 11 times a half squared. So 1 squared is 1 and 2 squared is 4. So we get 1 over 4. Plus we multiply this. This will be a half times k. Or we can say this is k over 1 times a half, so k by 1 is k over 2. So you can write that as k over 2 plus 7. So now looking at what's going on here, we have 6 over 1 multiplied by 8 over 1. So obviously 2 could go into 6 and 2 could go into 8. So you can do that cancellation. 2 into 6 is 3, 2 into 8 is 4. Nothing would cancel here, so you have 11 by 1 is 11 over 4. So let's write that out. So this would be 3 by 1 is 3 over 4. This 11 by 1 is 11, so 11 over 4. Plus k over 2 plus 7. And this is what f of a half is equal to. So this f of a half is equal to the remainder, which is also equal to this 3/4, take away 11 over 4, plus k over 2 plus 7. And we know the remainder is equal to 3. So since the remainder is equal to 3, f of a half is also equal to 3, because f of a half is substituting this answer here into your dividend to get the remainder of 3. And f of a half is also equal to this. So that would imply that the 3/4 take away 11 over 4 plus k over 2 plus 7 is equal to 3. F of a half is equal to this. F of a half is equal to 3. So these two things must be equal to each other. And that's what we have here. So what we could do, we could simplify this left-hand side. We have 3/4 take away 11 over 4. Denominators are the same. So you can just say 3 take away 11 and get negative 8 over 4. So I'll write negative 8 over 4 plus k over 2 plus 7 is equal to 3. Of course, negative 8 over 4 is equal to negative 2 because 4 into 4, 1, 4 into 8, 2. So we're going to have negative 2 plus k over 2 plus 7 is equal to 3. Then we could say negative 2 plus 7, which is positive 5. Or if you want, you could bring the negative 2 and the positive 7 together and then simplify it. So we have k over 2, take away 2 plus 7 is equal to 3. So again, negative 2 plus 7 is positive 5. So we have k over 2 plus 5 is equal to 3. We carry across the positive 5, we get negative 5. So we have k over 2 is equal to 3 take away 5. So 3 take away 5 is negative 2. So we're going to get k over 2 is equal to negative 2. And if you want, you could put a negative 2 over 1 and cross multiply. So now we could say k by 1 is equal to k. So we're going to get k like this. And then 2 by negative 2 is equal to negative 4. And that would be our answer. K is equal to negative 4. And that will bring us to the end of this video.